Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, welcome to Bohdi Park NEET and G Academy. So today we are going to discuss 10 MCQs based on projectile motion, that is motion in 2D or motion in a plane. So you can access various study materials using an app. You can download the app. The link is given in the description. So let's start with first question based on projectile motion. So look at this first question. A ball is projected horizontally from cliff of height 40 meter at a speed 40 meter per second. So it is projected horizontally. So suppose this is the cliff. Cliff can be called as mountain or it can be a building. So this is the ball. It is projected horizontally with 40 meter per second from the initial height 40 meter, and this is the ground level. Simultaneously, ball is dropped if time taken by the two balls to reach the ground are T1 and T2, taking air friction into consideration. So let's discuss how much time it will take. So you know, if we consider x direction and y direction separately, so this is the x direction and this is y direction. So y direction is negative. So along y direction, or we can say vertically, for the second ball, u is 0. And for first ball also u is 0 vertically, okay? Because you see the first ball, the initial velocity is horizontal. So vertical component is 0. So initial velocity is 0 vertically for both the balls. Now, as they will fall down, air friction is considered. So downward force is mg and upward force is air friction. So resultant force mg minus f is equal to ma. So acceleration will be g minus f by m. So if we consider both balls are identical, so mass will be same and the friction force is also same. So acceleration is same. So we have h is equal to half at square, okay, using s is equal to ut plus half at square. So u is 0, so s will be half at square, and the displacement is minus h in the downward direction, negative y direction. Acceleration is minus of g minus f by m, then into t squared. So this minus minus cancel, so h is equal to half into g minus f by m into t square. So we can find t from here. So for both the balls this time will be same, because for both the balls initial velocity is 0 and for both the balls acceleration is same, and displacement, vertical displacement also same for both the balls. Vertical displacement same. So time taken is also same. So T1 is equal to T2. Done. Now next question. Question number 2. Projectile is fired horizontally from top of tower, time after which instantaneous velocity will be perpendicular to initial velocity. Projectile is fired horizontally. So initial velocity is I cap, u I cap, and it is saying the final velocity is v j cap and acceleration vector is minus g j cap. So we have to find time taken. So we can use v vector is equal to u vector plus a vector into t. So v vector is equal to u I cap minus g into j cap into t. So time is always increasing. So we have both I and j component. So only j component not possible. Only j component is not possible. So the final velocity cannot be perpendicular to initial velocity. So v vector cannot be perpendicular to u vector, and we can also check it is a parabola. The path followed is parabola. So this parabola is not circle. Circle means the curve will come back. Okay, circle is like this. So at these 2 points, this is the initial velocity, this is the final velocity in circle. So these two are perpendicular, but parabola is not like this. Final velocity like this, initial velocity like this. So angle is always less than 90. So angle between initial and final is always less than 90 degree. Clear? So it is not possible. So it will never be perpendicular at any instant. Okay, done, finish. Now next question. Now look at this question number 3. A projectile is projected from ground such that 2 seconds before it reaches the highest point, it makes an angle 37 with vertical. Then the velocity of projectile at highest point. So let's draw the diagram. So this is the ground level. Now projectile is fired from the ground with initial velocity, suppose u. Projectile is fired from the ground 2 seconds before it reaches the highest point. Now this is the highest point. So before reaching the highest point, somewhere here, so this is the final velocity. Now this final velocity is making an angle 37 degree with initial velocity. Okay, so this is the initial velocity. So this is the initial velocity and this is the final velocity. The angle between them is 37 degree. So then the velocity of projectile at highest point. So at highest point we know that it is u cos theta. Velocity is u cos theta. So we have to find u cos theta. So let's use this concept. So x component is u cos theta, y component is u sin theta initially, and finally for final velocity the x component is v. Now this is 37 and a projectile is projected from ground such that 2 seconds before it reaches highest point, it makes angle 37 with vertical. Okay, I'm doing this question again. Okay, look at question number 3. Projectile is projected from ground such that 2 seconds before it reaches the highest point, it makes an angle 37 degree with vertical. So suppose this is the projectile path. This is the highest point, and this is the point of projection. So this is the u vector, and 2 seconds before reaching the highest point, suppose here, this is the final velocity. Now with vertical, it is making 37 degree. So the components will be, x component will be v sine 37 and y component will be v cos 37, and the time taken to reach the topmost point from here, suppose this point is A, this point is B, this point is C. So B to C time taken is 2 seconds. Time taken B to C is 2 seconds. Clear? So we can use the concept of vectors. At C, the velocity is u cos theta only in horizontal direction, and vertical component becomes 0. So let's calculate v cos 37 first. So vertically, v is equal to u plus at we are using, and b to c we are using. B to c, apply b to c, b is equal to u plus at. So final vertical velocity is 0. Initial vertical velocity is v cos 37. Acceleration is minus g, and time taken is 2. So 10 into 2 is equal to v into cos 37. Now cos 37, we can check this triangle. So this is 3, 4, 5 triangle. Angle between 5, 3 is 53. The other angle is 37. So cos 37 is 4 by 5. So this is 5 into 5. So we got v value as 25. V is 25. So v sine 37 is 25 into sine 37, which is 4 by 5. So this is 5 into 4. So this is 20 meter per second. Now horizontally, the velocity is same. Okay. So u cos theta is also 20, because horizontally there is no acceleration. No acceleration along horizontal. So horizontal component remains constant. So Vx is constant. Clear? So V sine 37 is equal to u cos theta. Both are equal, so answer is 20. Now done. Now next question. Now look at this fourth question. So we have a ball is projected horizontally from the top. Now look at fourth question. A ball is projected horizontally from the top of wall A of height 80 meter. So it is thrown horizontally. Initial height 80 meter. Speed 10 meter per second horizontally. At what distance from the wall the ball hits the ground? So its motion will be a projectile motion like this. So this is the range, horizontal range. So we have the formula for that. Range is equal to u into t, and h is equal to half g t square for horizontal projection. For horizontal projection. Clear? So let's calculate time from here. So, and we'll put here h is given 80. So 80 is equal to 1 by 2 into 10 t square. So 16 is equal to t square. So t is equal to 4. So range will be equal to u, which is 10 into 4. So it is 40 meter. Okay, done. So it will hit the ground 40 meter distance from the wall. This is the wall. Okay, finish. Now next question. Now look at this fifth question. Projectile is thrown with initial velocity vx I cap plus vy j cap. So this is the u vector given in ij form. So consider horizontal direction and vertical direction as x and y. So horizontal is x, vertical is y. Range of the projectile is 2 times the maximum height. So we know that range is r and the maximum height is h. So range is 2 times h. Now here we have a direct formula. Tan theta is equal to 4h by r. So tan theta is equal to 4 into h by r. So which is 1 by 2. So tan theta is equal to 2. We have to find vy by vx. Now u vector means it is a u cos theta I cap plus u sin theta j cap. So we have vy is equal to u sin theta and vx over here is equal to u cos theta. So vy by vx is equal to, now if you divide this, u and u cancel, so sin theta by cos theta, which is tan theta. 2. Tan theta is 2. Done. Finish. Now next question. Now look at this sixth question. A particle is thrown with velocity 40 meter per second. If it passes A and B as shown in the diagram, this is the projectile path of the projectile or the parabola. At time t1 and t2, which is 1 second and 3 second, what is the value of h? So let me draw the diagram once again. This is h, this point is A, B, and this point is C. So time taken from A to B is 1 second, and time taken from A to C is 3 seconds. For both A to B and A to C, displacement along y direction is same. Vertical displacement is same. So we can use, and acceleration along y direction is minus g. So we can use s is equal to ut plus half at square in the vertical direction. Okay. So in the vertical direction we have displacement is equal to h. So h is equal to u. Now u is vertically u is a u sin theta. And so this is u sin theta into t minus g by 2 into t square. So h is equal to u sin theta into t minus 5 t square. So let's make it in proper quadratic equation form. So it will be 5t square minus u sin theta, okay, 5t square minus u sin theta into t plus h is equal to 0. Now t1 and t2 are given. So we can use the product formula. T1 into T2 is equal to C by A, and sum formula T1 plus T2 is equal to minus B by A. So T1 T2 means 1 into 3. So 1 into 3 is equal to c by a. So this is ax square plus bx plus c equal to 0. So c is equal to h, a is equal to 5. So 1 into 3 is equal to c by a, so h by 5. So h is equal to 15 Newton. And we can also find u sine theta. So minus b by a means minus of b, which is minus u sine theta, by a, which is 5. Now that is equal to t1 plus t2, 1 plus 3. So 4 is equal to u sine theta by 5. So u sine theta is equal to 20. So we have solved this question. Now this is finished. Now next question. Now look at this 7th question. Two projectiles are thrown horizontally from high cliff in opposite direction. So if one is thrown right side, other is thrown left side. Speed is same. At what time their velocities are perpendicular? Final velocities are perpendicular. So suppose one ball is thrown right side with 20 meter per second and other ball is thrown left side with 20 meter per second. Now path followed will be projectile motion, parabolic path. So this is the path followed by first and this is the path followed by second. So we have to find after what time their velocities are perpendicular. So this is the ball, first ball is here after time t, at time t, this is the velocity, and over here the second ball, this is the velocity. Now these two velocities are perpendicular. If I draw this using a vector, it will look like this. Okay, so basically this angle will be 45 degree. So this is V, and with vertical and horizontal both it will make 45 degree. So what is the horizontal component? V cos 45, vertical component V sin 45. So we can use vertically V is equal to U plus AT. So minus V sin 45, it is downward, so that's why negative. U is vertically U is 0, A is minus G, and this is T. So this is V sin 45 is equal to GT. So T is equal to V by root 2 by G or V by G root 2. Clear? Now how to find V? Horizontally velocities are same. Horizontally velocities are equal. So 20 is equal to V cos 45. So V by root 2 is 20. So V is equal to 20 root 2. V is equal to 20 root 2. So we have time is equal to 20 root 2 by 10 root 2. So this is 2 seconds. After 2 seconds, the velocities will become perpendicular. So second option. Finish. Now next question. So look at 8th question. We have trajectory of a projectile in vertical plane y is equal to ax minus bx square, where a and b are constants, x and y are horizontal and vertical displacements. From point of projection, the angle of projection from horizontal r. So we have to find angle of projection theta. So we know that the equation of trajectory is equal to x tan theta minus half g x square by u square cos square theta. So using this we can compare tan theta is equal to a. Tan theta is equal to a. So theta is equal to tan inverse of a. Okay, direct formula. So fourth option. Now look at this ninth question. In the given diagram shown for a projectile, what is the angle of projection? So we have to find theta. So you see, in this parabolic path, so this is the point of projection. It is origin. So x is 0, y is 0, and for this point x is given 30, y is given 20. And range is also given. Range is 30 plus 10, so 40. So we can use the equation of trajectory. Equation of trajectory, y is equal to x tan theta minus gx square by 2 u square cos square theta. So we substitute x and y value. So x is 30, y is 20. So 20 is equal to 30 tan theta minus 5 into x square divided by u square cos square theta. And range formula is equal to u square sin 2 theta by g. So 40 is equal to u square into 2 sin theta cos theta by g. So using this we have 2 is equal to 3 tan theta minus 450 by u square cos square theta. Now u square value we will find from here. So u square is equal to 400 by 2, that is 200 by sin theta cos theta. So put it here. So 2 is equal to 3 tan theta minus 450 by u square, which is 200 by sin theta cos theta, then into cos square theta. So cos theta cancels, sin will go to the numerator. So 2 is equal to 3 tan theta minus 45 by 20, which is 9 by 4, and sin will go to numerator. It will become sin by cos, so tan theta. So 2 is equal to 12 tan theta minus 9 tan theta divided by 4. So 8 is equal to 3 tan theta. So tan theta is equal to 8 by 3. Okay, so that is second option. Okay, so done. Now next question. Now 10th question. Projectile is projected at angle more than 45 degree. Initial speed u, time at which magnitude of vertical component of velocity is equal to horizontal component. So we know that if this is horizontal component, so horizontal component remains same, but vertical component decreases. So initial vertical component is more, after some time vertical component is less. So we have to find t when Vy becomes equal to Vx. Now Vx is always u cos theta and Vy is equal to uy minus gt. Okay, using V is equal to u plus at. If we apply vertically, so Vy is equal to uy minus gt and uy is u sin theta. So u sin theta minus gt is equal to u cos theta. So gt is equal to u sin theta minus cos theta. So time is equal to u into sin theta minus cos theta bracket close by g. U by g sin theta minus cos theta. So second option. Okay, done. Thank you.